Look at this. Probability of any event is equal to number of favorable outcomes. Number of favorable outcomes divided by total outcomes. And usually this can also be written as probability of any event. It is very important, m by n. Now, example, we have to take the example of tossing a coin. Do you know tossing a coin? What is the probability of getting a head? Tell me. Probability of getting head. What is the probability? Head आने की probability कितनी है?
1/2.
Yes. And probability of getting tail, it is again 1/2.
1/2.
So from this, what do you conclude? A simple example is enough, but I will give you so many examples. You see, the
Okay.
total outcomes are 2. Denominator is total outcomes and numerator is number of possible outcomes. If you toss a coin, either head will come or tail will come. But from this, particularly if you want head, then head will come only one time. Similarly, tail will also come only one time. So probability of getting head is 1, tail is 1. And now if you add these two, sum of all the probability is 1. It's a second rule of probability. Sum of all the probability is 1. And probability value is either 0 or 1 or should lie between 0 to 1. It should not exceed 1. Your answer should not be more than 1. If you are finding the probability, your answer should not be more than 1. Okay, it should be less than 1 only, and non-negative also not possible. Tossing a coin, and another example, best example, rolling a die. Rolling a die. Rolling a die. How many faces are there in the die? Dice, we can
6.
say. 6 faces are there. Can you tell me what is the probability of getting the face is 1? 6 faces are there now. 1 आने की probability क्या है?
By 6.
1 out of 6. Probability of getting phase 2. Phase 2. Phase 1. It is 1 out of 6. Probability of getting phase 2. Again
2
1
by
out
6.
of 6. No, one time
Mm.
only. 2 will also
Oh,
come one time only. Probability of getting 3. Again it will also come one only, one only. So similarly, probability of getting 4. It is also will come only one time. Probability of getting 5. Phase 5 will also come only one time. Probability of 6. Phase 6 is also come only one time. Now you see, sum of all the probability 1 by 6 plus 1 by 6 by 6 is equal to 1. Means what I say, conclusion, sum of all the probability is 1. And the best example, one more is playing cards example. Playing cards. How many cards are there? Do you know? There are 52 cards.
52.
52 cards are there. Out of 52, 26 of them are red, 26 of them are black. Again, that 26 will be classified into 13 and 13. Then where the problem will come, I will tell you that one. I don't want to make you confused. So these three are the best example of probability. Tossing a coin, rolling a die, playing cards are the best example of probabilities. So I don't want to waste your time by giving so many examples. I will immediately come to your syllabus. According to your syllabus, you have to learn about conditional probability. Your first definition will start from conditional probability. Is the board is clear now?
Yes, sir.
Conditional probability. You need not to write anything, just to take the calculator with you. That's it. That's enough. Conditional probability.
Okay.
Okay. So now you see conditional probability, how to write. The conditional probability of A given B. We can't read as A by B. We can read as probability of A given B. Probability of A given B. Probability of A given B. The formula is probability of A intersection B by probability of B. Provided the condition is probability of B should not be 0. This is your first point of the conditional probability. Define conditional probability means you have to write this definition. Probability of B given A, which is equals to probability of B intersection A by probability of A. And this is also equal to, we can also write this one as probability of A intersection B and B intersection A. If you imagine the figure, I will visualize the figure. You can see that suppose this is A, okay, and suppose this is your B. Yes, you see, suppose this is your A. This is A, this is B, and this common part is called A intersection B. This is called, what do you call it as? A, the common area between A and B. A intersection B and B intersection A. If you find out, you will get the same answer only, no?
Yes.
So this B intersection A can also be written as A intersection B divided by probability of A. And the must condition is denominator should not be 0. If it is 0, then we cannot define it like that. This is the conditional probability. Okay, very, very important. This will help you to understand minimum 3 theorems. Conditional probability की base पे we have 3 theorems. So I don't want to waste your time. Immediately I can go for one theorem. Question is,
Okay.
state and prove. State and prove. Multiplication theorem on probability. It is for 2 marks. Multiplication theorem on probability. It is not specified in your syllabus, but without addition and multiplication, there is no concept of probability. State and prove multiplication theorem on probability. So a statement also you have to write it, and then proof also you have to write it. So I will just make a heading, side heading, that is statement. Statement. Look at that. What is the statement? Statement also you should write it, and proof also you have to write it. Okay? State and proof.
Yes.
So what is the statement say here? If A and B are 2 events, A and B are 2 events. A single word also, if you don't understand, like example, if you don't know what is the meaning of event, that also you can ask me. Event of a random experiment. Random experiment. A and B are 2 events of a random experiment with probability of A should be greater than 0, comma, probability of B is also greater than 0. Then we have to prove the result as probability of A intersection B is equal to, we have to prove this one. It is also equal to probability of A into probability of B given A, which is also equal to probability of B into probability of A given B. This result we have to put. Okay. What I want to say statement, A and B are any two events. Like this only the best example. A and B are any two events of a random experiment. Okay, and A should be positive, B should also be positive because we are talking about probability. Negative values are not required, not necessary, not possible. So this result we have to prove. Okay, I'll go to the next page. I'm writing the proof of this. Proof of this probability. You understand the statement? Okay.
Yes, sir.
See, we have to say without looking one time. एक बार आप खुद से बगैर देखे बोलिए. Let A and B are any two events of a random experiment with probability of A greater than 0, comma, probability of B greater than 0. Then probability of A intersection B is equal to probability of A into probability of A given B. A into B given A, B into A given B. That's it. This result we have to prove. So by definition of conditional probability, just now we have done conditional probability definition. You will get it for 2 marks also. It is also possible. What is that? Tell me. Probability of A given B. In other words, we can say probability of B where A is already happened. ऐसा भी पढ़ते हैं इसको, but no problem. A given B is enough. This is equal to probability of A intersection B by, come on, tell me.
P of P.
Probability of,
P
no,
of
no,
P.
don't say P of, probability of. Make a habit of
Probability.
reading as probability. Probability of B should not be 0. Should not be 0
Yes.
means, of course, it is positive only. If you cross multiply, then what you will get it? Probability of B
B by A.
into probability of A given B. A given B. A given B. Reading habit. A
A.
intersection B. Let us call it as equation number 1. Also, we have one more point of the conditional probability definition, that is probability of B given A. According to the definition of the conditional probability, this can be written as probability of B intersection A by
Intersection A.
probability of A.
Probability of A.
But this can also mathematically can be written as, if you visualize the figure also, I have given example, A intersection B and B intersection A, mathematically they are equal only. So it is also equal to A intersection B by probability of A. And this part will be probability of B given A only. Now, once if you cross multiply, we get probability of A into probability of B given A is equal to probability of A intersection B. Now, this is taken as equation number 2. Now, if you combine these two from 1 and 2, what do you say? It is the value of intersection B. It is also the value of intersection B. So means if you merge these two results, what you will get it? Tell me. If you merge these two results, what you will get it? I will get my answer is probability of A intersection B is equal to, choice is yours. You can either write the first or you are write it second, no problem. This is A into, it is B given A, which is also equal to probability of B into probability of A given B. Hence the result is true. I hope you understand this. Is this everything is clear?
Yes.
Yes. What we have done just now, we have done a definition of conditional probability, and immediately using the definition of conditional probability, we have proved multiplication theorem on probability, which will help you to understand, to solve so many problems of the M3. After that, we have a small definition which is called probability function. Probability Probability function. Probability function. Everything is important. What's your name?
Veriha, sir.
Yes. Mariha, whatever. Everything is important, whatever I'm giving. It's a point to point from your syllabus only. Okay. Now,
Okay,
what
sir.
is the definition of probability function definition is a function, a function, a function P maps from A to B. We read it as P maps from A to B is said to be is said to be probability function is said to be probability function is said to be probability function if very simple way I'm using it satisfies. I am just converting the textbook definition in my words. A function P maps from here somewhere it is given some row symbol is using. I'm using a very simple because we are using most of the time probability. So probability is a function said to be the probability function if it satisfies the following conditions. Following conditions. So if you want to say it is a probability function, it should satisfy the following conditions. What is the condition? Number one. Condition number one. Condition number one is what you see. Probability of A union B can be written as probability of A plus probability of B. That's it. So I will explain this one with the help of a small figure. You see here. Yeah, only I'll take it. Suppose this is your set A. And here only I'll take it. This is your set B. A and B. Now look at that. Suppose this is your set A. This is your set A. And this is your set B. You see, is there any common area between A and B?
No.
No, no common area. Very good. So if a situation will come across like that, where A and B are two events in a sample space capital S, this is your sample space capital S, okay, and there is no intersection part, then probability of A union B can be written as probability of A plus probability of B. Simple words, we can say union will be converted to addition. Simple way, union will be converted to addition. Please note my words. Union will be converted to addition. Union will be converted to addition. Union will be converted to addition. Very important point. Okay, once if I am doing the Bayes theorem now, this part, this voice will come again and again. Now, second condition is probability of empty set is equal to 0. There is no chance of getting empty set. Probability of empty set will be 0. Empty set, do you know what is empty set? Empty set means we don't have any element in that set. Empty set.
Yes.
Like this is if you have only one element, it is called singleton set. Okay, this bracket is using to represent the sets.
Yes.
Already 8th class, I think 10th class also there. And probability of A complement. Complement of any probability is equals to, what do you say? 1 minus probability of A. Okay, from 1 we have to subtract. And Very important fourth one. Probability of S is equals to 1. This one I want to write in words also. Sum of all probabilities is 1. Sum of all probabilities is 1. In words I'm writing. It's very important because we're using so many times this one and this one. So now fifth property is, but this will not come in exam. It is only to understand. Probability of any event should be greater than or equal to 0. And then sixth property will be the value of any probability. The value of any probability should lie between 0 to 1. Answer of any your probability answer should lie between 0 to 1. This is the concept of probability function. I hope everything you are understanding. Okay, and this class, if you understand after a few minutes, please give me a feedback whether you are, how much percentage you understand, so that I can schedule one more class today only. Today only, I want to go for one more important theorem, that is addition theorem, and one more is Bayes theorem, because we have only 4 minutes time is left. If I start also, addition theorem will not be completed. It is taking minimum 10 to 12 minutes to explain, so that I am now ending the session here only. If you are comfortable and if you understand, please let me know so that I can plan for one more class today only. Okay? Okay?
Okay.
Okay, thank you. I'm ending the section.
Okay. Thank you.